everyone, it's Joyce here. Now I'd like to share with you on some concepts of electrolysis. So today I have selected a few questions from the 10-year series to share with everybody. Alright, so first of all I have a question that says which processes involve the movement of the ions? Right, so in this question it shows three different processes. Now in the process number 1, it shows the application of a light bulb. Now we know that a light bulb uses its metal filament to conduct electricity. And why do metals conduct electricity? Because metals have the mobile electrons. So these mobile electrons are able to carry the or able to act as the electrical particles, right, to conduct the electricity. So as a result, we can see that the process 1 is not the answer because it does not involve the movement of the ions, but instead it involves the movement of the electrons. Right, so let's take a look at the process 2. Now in the process 2, it shows an example of this simple cell, where the simple cell is set up by using the zinc electrode and the copper electrode. Now we know that the zinc metal is a more reactive metal than the copper, as we have learned in the chapter on metals under the reactivity series. So as a result, zinc metal loses the electrons more readily to undergo oxidation than the copper metal. Alright, so at the same time, what happened at the copper electrode is that the H+ ions from the electrolyte, which is the dilute sulfuric acid, will be discharged, alright, towards the copper electrode. Alright, so this involves the movement of the H+ ions, and therefore there will have movement of these ions in this simple cell, and hence process 2 is one of the answers. Alright, so what about the process 3? Now in the process 3, it shows the electrolysis of the dilute aqueous sodium chloride solution. So in the dilute aqueous sodium chloride solution, we have ions such as the Na+, the H+ ions, the Cl- ions, and the OH- ions. Right, so what's happening in this electrolysis setup is that at the anode, we will have the hydroxide ions to be discharged, because hydroxide ions is more preferred to be discharged than the Cl- ions. So as a result, it produces the oxygen gas and the water at the anode. So on the other hand, at the cathode, we have the H+ ions to be discharged, because the H+ ions is more preferred to be discharged than the sodium ions, and hence the H+ ions discharge to produce the hydrogen gas. Right, so you can see that in the whole setup, the H+ ions and the hydroxide ions are being discharged at the respective electrodes, and this shows that there's movement of the ions, and hence process 3 is also one of the answers. Right, so therefore we have option D as the answer. So let's go on to the next questions on the concepts of this electrolysis. Alright, so I have a question here which shows a picture of a simple cell. Alright, and then this simple cell is being set up by using the silver electrode and the magnesium electrode. Alright, now first of all, in the chapter on metals under the reactivity series of the metals, we know that the magnesium metal is a more reactive metal than the silver. Right, so you should expect the magnesium metal to undergo oxidation more readily than the silver, which means that the magnesium metal has a higher tendency to lose electrons more readily than the silver metal. So as a result, you will expect the electrons to flow from the magnesium electrode to the silver electrode. Alright, so I've also indicated the direction of the electron flow in the picture, alright, on the external conducting wire. Alright, so this is how the simple cell works. Alright, so based on option C, we can see that the magnesium electrode loses electrons in this application to undergo the oxidation. Alright, so let's discuss about the other options. Why the other options are not possible? Alright, so let's look at the option A. Electron passes from the magnesium electrode to the silver electrode through the electrolyte. Now, in fact, electrons do not move through the electrolytes. Electrons will move through the conducting wires. Alright, so that's why answer, as in the option A, is not correct. Now what about the option B? Silver is more reactive than magnesium. Well, this is what we have already discussed earlier on. It should be magnesium is more reactive than the silver. Alright, and lastly, for the option D, silver electrode is oxidized. Now, in fact, the more reactive metal will undergo the oxidation because they will lose electrons more readily. So since silver is a metal that's of a lower reactivity than this magnesium, silver does not undergo oxidation at all. Alright, so therefore we have the answer as C. And the next questions I have here with me is the questions on which ions are present in the aqueous copper 2 chloride. So in this aqueous copper 2 chloride solution, we have to identify what are the ions that are present in this solution. Now, first of all, aqueous copper 2 chloride solution means that the copper 2 chloride salt has been dissolved in water. So in this solution, it is not only present with the Cu2 plus ions and the Cl minus ions from the copper 2 chloride compound, but there is also H plus and OH minus ions that comes from the water. Alright, so as a result, there are 4 different types of ions that are present, which are the copper 2 ions, the chloride ions, the hydrogen ions, that's the H plus ions, and the hydroxide ions, which are the OH minus ions. Alright, so therefore we have the answer as D. Okay, and the next questions that we're going to look at will be this question that says, what happens to the ions that move to the negative electrode during the electrolysis of the molten potassium iodide? Alright, so in this molten potassium iodide, there are only 2 types of ions that are present, and they are mainly the K plus ions, that's the potassium ions, and the I minus, which is the iodide ions. Alright, so you can see that at the negative electrode, which is the cathode, it will always have the cation ions to be discharged towards these electrodes. Alright, so since K plus ions are the only cation ions present in the molten potassium chloride, you should expect the K plus ions to be discharged towards the cathode, and that is undergoing the reduction. Alright, so as you can see from these half equations that I've written here, we have the K plus ions undergoing reduction, that's gain of electrons, to form the potassium metal. Now keep in mind that the potassium metal formed in this application must be in the molten state, right? Because the electrolysis of the group 1 metal compounds or the salt will usually be done at a very high temperature. Alright, so at that temperature, the potassium metal that we have obtained will exist as a liquid or in the molten state. Right, so therefore, the positive ions that are discharged at the cathode will undergo reduction. Right, and that's why the answer is A.